morning with you, Miss Yasmin, science teacher. We are going to cover today Unit 2, Lesson 1, the mirrors. First, why we see ourselves in the mirror? We see ourselves in the mirror due to the light reflection. What's meant by light reflection? It is returning back of light or bouncing of the light when it falls on the reflecting surface. So here, slide number 2. What is the light reflection? It is a bouncing of light or returning back of light when it falls on the reflecting surface. Here, as shown in the figure, we can see incident light ray, reflected light ray, angle of incident and angle of reflection. And between them, there is a line which falls perpendicular on the reflecting surface. The line which is fall perpendicular on the reflecting surface is called the normal. And the incident light ray, it is light ray which fall on the reflecting surface. And the reflected light ray, it is a light ray which is returned back from the reflecting surface to our eyes. What is the angle of incident? It is angle between incident ray and the normal. And what is the angle of reflection? It is the angle between the normal and the reflected light ray. So here we have reflecting surface and we have line which is fall perpendicular on the reflecting surface, which is called normal. Between the incident ray and the normal, there is angle which is called angle of incident, and between the normal and the reflected ray, there is angle which is called angle of reflection. Slide number 3. What are the laws of the light reflection? First law, angle of incident equal angle of reflection. What is the second law? The second law, the incident light ray, the reflected light ray, and the normal line to the reflecting surface at the point incident all are on the same one plane perpendicular to the reflecting surface. Here there is a relation between angle of incident and angle of reflection. So here we have a figure that shows a relation between angle of incident and angle of reflection. Here we have the first law, angle of incident equal angle of reflection. This means that if the angle of incident equals 60 degrees, so the angle of reflection equals 60 degrees. And if the object falls perpendicular, so the angle of incident equal angle of reflection equal 0. Slide number 4. Types of mirrors. Now we are going to take the types of mirror. There are two types. The first type, it's called plane mirror. What is a plane mirror? It is a piece of glass painted from outside by thin layer which is silver metal. Slide number 5. Properties of the image formed by the plane mirror. Here we can see ourselves in the mirror. Here as shown in the figure, we have object and the image. First we can see the object which is red and the image on the other side. Here we can see it is upright, it is virtual, it is equal in size, and it is inverted. And the distance between the object and the mirror equals the distance between the mirror and its image. Here we can make straight line, join the object to its image is perpendicular to the surface of the mirror. Here, what are the properties of the image? They are upright, they are equal in size, they are virtual and inverted. Slide number 6. The second type of the mirror is called spherical mirrors. Spherical mirror, it is a mirror whose reflecting surface is part of the hollow sphere. As shown here in the figure, we have two types of spherical mirror, concave mirror and convex mirror. Concave mirror, as shown in the figure, it is going to collect the light ray, and the reflecting surface is the inner part of the sphere. And the convex lens, the reflecting surface, is the outer part of the sphere, and it is going to diverge the light ray which fall on it. So here we have two types of mirrors, concave mirror and convex mirror. The concave collects the light ray and the convex diverges the light ray. Here, what is the mirror whose the reflecting surface is the inner part of the sphere? It is called the concave mirror. And what is the mirror whose the reflecting surface is the outer part of the sphere? It is convex mirror. Slide number 7. Concepts relation to the spherical mirror. Here we are going to take Center of curvature, the symbol is C as shown here in the figure. We can see the letter C. What is C? C is center of curvature. It is the center of the sphere that the mirror is considered part of it. What is the radius? The radius, it is a straight line or distance between center of curvature and any point on the reflecting surface. Slide number 8. Here we have ball. What is the ball of the mirror? It is a point in the middle of the reflecting surface. As shown here in the figure, we can see the ball of the mirror. The symbol is B. It is the point that lays in the middle of the reflecting surface of the mirror. What is the principal axis? It is the distance. It is a straight line between center of curvature and the ball. What is the secondary axis? It is the distance between center of curvature and any point on the reflecting surface except the ball. So here the ball B. And principal axis and secondary axis. What is the distance between center of curvature and the ball? It is principal axis. What is the distance between center of curvature and any point on the reflecting surface except the ball? It is secondary axis. And the ball, it is the middle point on the reflecting surface. Slide number 9. Focus of the mirror. Here we have two foci. First, the real point of collection of the reflecting light ray. And the second, it is extension of the reflected light ray. So we here have concave mirror and the convex mirror. On the concave mirror, we can see the focus in front of the concave mirror, and it is point for collection of the reflected light ray. And in the convex mirror, we can see the focus behind, and it is extension for the light. Focal length, the symbol is F. It is the distance between center of curvature and the ball. Here, slide number 10. Summary. We can see here the sphere, the center of curvature in the middle. Here we have concave mirror and convex mirror, and we have two balls. The ball in the middle of the reflecting surface. And here we have principal axis, distance between center of curvature and the ball. And we have secondary axis, distance between center of curvature and any another point on the reflecting surface except the ball. Slide number 11. The focus of the concave mirror. Focus of the mirror F, real point of collection of the reflected light ray. Virtual point of collection of the extension of the reflected light ray. Here we can say that radius 2 multiply focal length. So the focal length, it is the distance between focus and the ball. Slide number 12. Now we are going to take some rules. Here we have concave mirror. In the first figure, we can see that when light ray fall perpendicular on the reflecting surface, it return back to the focus. So when the light fall perpendicular to the principal axis, it pass through the focus. Here we have number 2, if the light ray pass through the focus, it return back parallel to the principal axis. 3, if the light ray pass through the center, it return back on itself. So here we have rules. Number 1, the incident ray fall on the concave mirror, so it is parallel to the principal axis, so it pass to the focus. If it pass to the focus, it return back parallel to the principal axis. So if it is pass through the center of curvature, it return back again on itself. Slide number 13. Properties of the image formed by the concave mirror. Here we can see concave mirror. Object position, very far. Image position at the focus. Properties, it is real and dot. Slide number 14. Now we are going to take properties of the image formed by the concave mirror. Here we have ball, we have center of curvature, and between them there is focus. There is point which is called focus. Here we have object. The object here is far from double the focal length. So the object position, distance greater than center of curvature, or more than double focal length. What is the image position? The image position between focus and center of curvature. Here, what is the properties? They are inverted, they are minimized and real. Again, if we have object and it is far from center of curvature, the distance greater than center of curvature. So we can see here the image at distance between center and focus. And here the properties, it is inverted, real, and minimized. Slide number 15. If we have the object stand on the center of curvature and the light ray fall perpendicular on the concave mirror, it returns back and pass through the focus, and this image here is again on the center of curvature. And the properties, it is real, inverted, and equal in size. So the properties is real, inverted, and equal in size. Slide number 16. Here, properties of the image formed by the concave mirror. Here we have the object between center of curvature and the focus, and the light fall on the concave mirror, return back through the focus, and form an image far away from center of curvature. So the object position between focus and center of curvature, and the image after center of curvature. What are the properties? It is real, inverted, and magnified. Slide number 17. Properties of the image formed by the concave mirror. The object position, if it stands on the focus, so the image, there is no image is formed. Here at focus, there is no image formed. Slide 18. Here we have the object between the focus and the ball. So the object position between focus and the ball, and here we can see the image position behind the mirror. So we can make here light ray fall on the concave mirror, and there is extension for this light ray, so the image formed behind the mirror. The properties is virtual, upright, and magnified. Slide number 19. Uses and importance of the concave mirror. It is used as a torch in front light of cars. Slide 20. Uses of concave mirror in shaving, in marine lighthouses. Slide number 21. Uses of concave mirror in aircraft landing at airports, as shown here in the figure, or in the solar ovens. Slide number 22. Properties of the image formed by the convex mirror. Properties here, virtual, erect, and dimension. So we have two parallel lines, so there is no image formed when it is stand on the focus. If here the object stand on the focus, there is no image formed because they are parallel to each other. As shown in the figure, we have two light rays which are parallel. Slide number 23. Uses of the convex mirror. Car side view mirror. Slide 23. Uses of convex mirror. Car side view mirror, as shown in the figure. Also in the mirror in the supermarket, as shown here in this figure. Slide number 24. Uses of convex mirror. Mirrors in U-turns. We can see these mirrors in the street. Here, slide number 25. Real image. Here we are going to take real image and virtual image. What is the real image? Real image is always inverted, but the virtual image is always erect. The real image is always inverted and can be received on the screen, formed of the intersection of the reflected light ray. So here we have real image and virtual image. The real is always inverted and the virtual is always erect. And the real image can be received on the screen and the virtual can't be received on the screen. So slide here number 25, we can see the real image always inverted, can be received on the screen, formed of the intersection of the reflected light ray. Slide number 26. Virtual image. It is always erect, can't be received on a screen, formed of the intersection of the extension of the reflected light ray. So we have compare between real and virtual. Here real and virtual, the virtual is always erect, but the real is always inverted. Here the real can be received on the screen and the virtual can't be received on the screen. Slide number 27. Questions. Give reason. Here we can see the ambience word is written in a lateral inverted way. Why? Give reason. Because front car is a plane mirror, so people can read it in a correct way. 2. The incident light ray falling perpendicular on the reflecting surface reflected on itself, because angle of incident equal angle of reflection equal 0. 3. A convex mirror is put at the left side of the mirror to form small erect image of what is behind. Slide number 28. Complete the following. Here in the first figure, we can see line fall perpendicular on the reflecting surface. Here we can see that angle of incident equal angle of reflection equal 0. In the other figure, if the light ray fall on a concave mirror and pass through center of curvature, what happened? It will return back on itself again. Here if we have a person stand 3 meters from a plane mirror, what is the distance between the person and his image? The distance between an object and the mirror equal distance between the image and the object, so the distance equals 3 plus 3 equals 6 meters. Thank you.